Okay, hyvää huomenta or good morning to all of you who have already came here. Let's start today's, or this is morning here in Finland, 8 a.m. Kello on 8 aamulla here. Kello means the same as clock or bell. Bell is 8 in the morning here, if we translate it. We went through those calculation problems in this skills test, these 20 exercises there. Yesterday we got that through, if I remember correctly. We had all 20 problems solved, but now we will go to this rectangular triangle or right angle triangle, and I will write the word here. In Finnish it is called suorakulmainen kolmio. Right-angled triangle, or as I wrote in this test, rectangular triangle. Probably there are also more names for this triangle, but I think these are most common. First, notation of the parts of triangle. In this test, I use this kind of simple picture or drawing of the triangle, and there it is shown that in this rectangular triangle or right-angled triangle, you have 3 sides, A, B, and C, and this longest side is called C, or notated with the letter C. And these sides, sides which are rectangular to each other, or those sides that form this 90 degrees angle, those are called cathets and or legs sometimes, and this longest side is called hypotenuse. I will write the Finnish names for those parts here in the paper. So if I have here A and here B, A and B are kateetit, or this is A is kateetti and B is kateetti, but if there are 2 of them, they are both called kateetit. Many kateetti are kateetit. Mostly in Finnish words, if you see the last letter T, it means that there are many of those. I've forgotten the word in English.
Plurals.
Sorry, can you repeat?
Plural. It's plural. Singular, plural.
Yeah. Okay, now I understand. Yeah. Plural. Yeah, plural. That is one word in English which is hard to pronounce for a Finn. Plural. We don't have that kind of words in Finnish language, so it sounds strange when I try to say plural. Many kateetti, plural, kateetit. And C is in Finnish called hypotenuusa. hypotenusa. I think those names come from Greek language, if I'm correct, and it is the longest side in this triangle. C is always the longest leg, or longest side of triangle, but A and B, they can, it doesn't necessarily mean that A is the shortest one and B is the second one. Those can, A may be longer than B, so this is not any this is just some kind of simple figure of triangle. And then there are two ways to notate angles. In Finland, we mostly use this method, like in this picture. We use these Greek letters here, alpha and beta. This is most common way in Finnish mathematics, and I'm not sure how popular this method is in other countries. But also it is used the method that we use the bigger letters. If we have this A letter here, as we say, it's small a, and here we get bigger A or large A, and same goes with this corner here. This would be called B, big B or large B, and you may notate that point with that letter, or also that angle with that letter. So it is quite usual to use A for the name of this alpha and B for the name of this beta. Then there is this last corner in this rectangular triangle or right angle triangle. I'm somehow more used to this rectangular, and I know that many of you prefer this right angled world, but it's the same. So this is the C, big C or large C here. Important thing is that always this big A here, or this angle A here, or alpha here, is opposite of the side A or leg A here, in the other side of the triangle, opposite side. And same with this B or beta here, it is always on the opposite side of as this B here. And C is also so in this right angle triangle, this hypotenuse, hypotenusa, C is always opposite of this right angle or 90 degrees angle here. Some words in Finnish. Angle is kulma. And degree. Let's say, take an example. For example, 40 degrees. 40 degrees. This is in Finnish 40 astetta. Neljäkymmentä. I should throw these dry pens away, but always I take them with me in another class, and always I have problems with these dry pens. 40. This 10 was 10, and neljä is 4. So this means 4 of tens. One word also. Area or surface area is pinta-ala. Or simply ala. Pinta-ala area, the surface area of, for example, a triangle. This pinta here is actually in Finnish language it is same as surface. The surface of my skin is this is iho, my skin. The surface of my skin is pinta. Okay, and then the rules here in these first two problems in this test was asked the length of A and length of C, and the situation there was that we knew the other sides of the triangle. Here we knew B and C, and we needed to calculate the length of A. And here we knew A, and I had a miswriting there first. There in that test they wrote C, but we corrected it. It was B, meant to be B. So there we needed to calculate the length of C with knowing that A and B are these numbers here. And then we were asked to get answers in meters and rounded to 3 decimal places. So we have some rules. Let's take this most simple rules. In Finnish, I again has this formula, book of formulas, if I find the word here. Here it is written suorakulmainen kolmio or rectangled triangle, right-angled triangle, Pythagorean lause. This is Pythagorean lause or Pythagorean theorem of Pythagoras. A squared plus b squared equals c squared. Here you see ala word. It is the area of triangle. As I told you, you may say it pinta-ala or simply ala. In Finnish, Pythagorean lause. Pythagorean theorem. C squared equals a squared plus b squared. So now in problem 21, we knew that B equals 22.163 meters. In Finland, if you look at Finnish mathematical books, mostly you see now help me to remember what is this. This is not dot in Finnish, but it is comma. Is it comma? Decimal comma. We use mostly that. I'll try to find an example from this book if I found it. For example, here we have normal distribution table there, and if you watch the numbers there, so there are these not points but commas. Yes, comma in English. But in my text, I usually use that point, as you see, because I like more this method as this official Finnish way to write those decimal numbers. But in written text, I may be when I write with my hand, I am so used from my school times that to use this comma, so it comes in my written text, handwriting. But when I write with the computer, I always use these points. And C equals 45.218 meters. And A needed to be calculated. So how do you calculate the A from the Pythagorean theorem? Sometimes in formula books they have already solved that. Yes, in this book also I'm not quite satisfied with this method, because this is quite simple to solve A from that equation. But if, like you see in this book, there it is written how you may solve A from that Pythagorean theorem. Here you see that. But actually, we will take this Pythagoras. I write it only Pythagoras here, and we had this c squared equals. We will start with this basic form. Of course, that could be written in the opposite direction, like in this book. It is written so that this c squared is in the right hand side. That is probably better way to use that order, because it is easier to solve A and B with this equation formula. But I'm used to use this format here. So A need to be solved. So we solve this equation just by moving this b squared to the left hand side. So we will change the sign of this b squared, so we will get c squared minus b squared equals a squared. And of course, we may read this equation from right to left. So it says us to that a squared equals this here. So when we need to find out what is the value of A, we will take square root. So this means that A is equal as square root of this, as we saw in this formula book. There was shown that. By the way, this neliöjuuri is square root. Yesterday we had some Finnish words concerning geometry. Here we have had this word square, which meant either this figure of square or this exponent 2 or power 2, neliö. And here we see the neliö again. And root is the same as juuri. In Finnish language also this root is when we have I'm a very bad drawer, but if we have a tree here and here which are in the ground, this part here, this is juuri or root. I'm sorry of my bad drawing skills. Neliöjuuri. So now A equals c squared. I won't write the dimensions here or units here. I only write these numbers. C squared minus b squared, and then square root, and meter is the correct unit. Let's take a calculator to so you get this kind of result there. 39.41407, etc. Now I try to use that point. And then in the problem it was said that it should be rounded to round it to 3 decimal places, and that means that we have to leave 3 decimals or 3 numbers after that point. So when we go take away the that part of there, we now have the 3 decimals, and there is the next figure there is 0, so the 4 will stay. So here you see the correct rounding to 3 decimal places. Mostly in this problem, in test, if you got those points, if you got 0 point, that 0 points, that usually means that you had made some error in this calculation, you didn't get the right answer. But if you got half points, that probably means, for example, in this problem, that you had calculated it correctly but rounded it wrongly, not in that precision as it was said 3 decimal places. So it means that you have three decimals after the point. Of course, always in this kind of geometric problems, especially when we are going through or calculating with not right angle triangles, but universal triangles in where there are no 90 degrees angles at all, it is many times useful to try to draw that triangle at least somehow in scale, so you may check your answer with that picture. And for example, in this point, I may try to draw this this triangle. I won't do this in so many exercises, but in this time I will do. For example, I have B and C. Those are 22 and 45 meters about. If I made that kind of scale, that I will have. I double those numbers, so this will be in 44 and this will be about 90, and I will use this my ruler here, and so B would be 44 in my scale. I will write 44 here. 44 is about here, and this is the length of B, and then the C was 45, so in my scale it means 90. I draw this stupidly. I don't have enough place for either in the top part or bottom part of this picture. I will draw again. I will draw the B here. As I said, it was 44, double the 22. So it is here. And then I have a right angle here. So this is B, about 22 meters, and I draw it with the length of 44 millimeters. So here must be right angle, and somewhere here there is the side A. We don't know the length of A. We are calculating that, or actually we know that, but if we want to check that. So B is 22 meters and this C is 45, so I will double it and write it 90 millimeters in my picture. So I try to find the 90 millimeters. There is 9 centimeters there, and if I write this triangle about here, so it will be almost in the scale. Here C equals about 45 meters. So now I may take the ruler and measure the length of A, and remember that I doubled the measure here. So in my scale now I see that this is about 70, I would say 78 millimeters. 78 millimeters, and that is double the correct. So 78 divided by 2 equals 39. You don't see that. 39 meters. So we got 39.4. So probably we have made the calculation correctly. This takes some time, but I think that in some kind of test situation or exam situation, it is good to somehow check your calculations. Mostly you don't need necessarily exact rulers. You may draw the drawing by hand and just trying to get such good picture as possible, but mostly you see the biggest mistakes from picture. For example, if you get this, for example, 20 meters, so of course you could see from the picture that if B is 22, so this A must be much longer than B, and if you had got here 20, so you may be sure that you had made some mistake. Then the number 22, there was almost similar problem. These first two problems in this triangle test were problems where you needed that Pythagorean theorem, Pythagorean lause. now we know A and B when we corrected this letter to B. A equals 30.531 meters, B like this, and C is unknown. Not well. This is simpler than the first example. We had this Pythagorean theorem, which it almost tells the answer. You know what is C squared, so you only have to take square root of that right hand side there. Pythagoras, C squared equals A squared plus B squared, so you will get C with the help of square root. It depends on your calculator, how do you solve this. This calculator, which I have here now in my hand, it gives you possibility to write the mathematical expression exactly like it is written in paper or book. So you may use this square root there like that. But for example, more simple calculators, I think I got my old calculator with me. Oh, then, yes, here it is, very old calculator. This is probably from the year 1984 or so. So it is over 40 years old calculator. It is almost broken. I have taped that. And in this calculator and in many other calculators, you need to first calculate this value inside the root. So I will do that with this. I like these older calculators more than these newer ones because those numbers are so big. For example, especially when you get older, you can't see well. So these big numbers helps me to see those numbers correctly. That was 30 squared about, and then 22.525 squared and equals. So this number is inside the square root, and then we take that square root with this button here. And here we get results. Earlier times it was easy to use calculators because they all had almost similar logic there, but nowadays there are so many different kind of calculators, and also with phone application, mobile phone application. So you always have to try to remember how to use that calculator. Okay, again I will write some extra decimals there, and after that I check what was the precision asked, and it was again 3 decimal places in this problem also. So now 3 decimals is here, three figures after the comma or after the point, and now the next figure is 9 and it rounds this number up, So it won't be 940 but 941 because of that 9 there. So this is rounded to 37.941 meters. I guess many of you got half points because you have had rounded this 940. That is rounding by cutting, but actually it is more near 941 than 940. Well, these are very small things actually. The most important is to get the correct answer. This rounding is more case of opinion. And of course, here also we could try to check the answer. A is some about 30 meters and B is 22. So this longest side of the triangle hypotenuse must be longer than longer ones here. So this is longer. So the answer must be longer than this A. And it seems to be, so I guess it is okay. And of course I could drawing in scale and check with the help of that, but I will leave that for an exercise to you. Okay, these were cases where from the right angle triangle you knew two length of two sides. By the way, the word length, this is in Finnish pituus. Long is pitkä in Finnish. That is the word for which is the first form of this word pituus. Pitkä is long, and so pituus is it tells how long you are. Yes. So next we will go to these trigonometric functions. In Finnish, almost the same. Trigonometriset funktiot. In Finnish language, we actually don't have C letter at all. Mostly it is in the place of C, there are K letter. By the way, if you could please do so that everyone who are there online would write to the chat box which way is more how are you used to have these Greek letters in the place of angles, or I will show in this picture. Are you used to have this alpha and beta there, or these big large numbers A and B? Is it which is more popular in your countries? Or do you use another markings there? Because I actually don't know. there may be, and again, alpha and beta are fine large number. Yes, there are different habits. Alpha, beta, gamma symbols. If you are listening to this video later, or recording later, I'm reading those chat writings there. Alpha, beta, gamma symbols are used in our country, yes, but also these large numbers. Yeah. Again, I would like to see if you have some book of formulas, pictures of, for example, so pictures of a square. So maybe I would see what kind of notations you have. Yes, capital is the right word. In Finnish we say large number, big number, iso numero, ja iso kirjain, big letter, and small letter, pieni kirjain. But it is capital. I think it is the correct word for in English. Well, I will use both ways here, so it is not I will be so everyone will see examples with the way which he or she is used to. For example, if we have big letters here, or capital letters, so we have like this, and then we have trigonometric functions. Most common are sin, cos, tan, or sinus, cosinus, and tangent, or sine, cosine, and tangent, which mostly are shown in these calculators. In these older calculators, there usually were only these three ones, sin, cos, tan. But nowadays, in many, or at least in some calculators, for example, in this calculator, there is a button trick here, and if I push that button, there comes a table where I'm sorry, I can't show that well enough, but you may see the sin, cos, tan, and then there is cosecant, secant, and cotangent, and then these inverse versions of those. So in this calculator, you may take everyone there, or find every trigonometric function there. But well, I have to say that I mostly have taught, been teacher for civil engineering, and in their studies, I would say that sin, cos, tan are enough. Sometimes they need cotangent somewhere in some concrete calculations. I mean material called concrete, cotangent, but these cosecant and secant, I don't know if they have. I have ever seen in civil engineering applications those functions. I use them so rarely that I always have to try to remember again what does mean secant and cosecant, because I have not found any applications for them. Yes, okay, trigonometry. Yeah, thank you. So let's start with sine. Or sin A, or alpha. I found a page from internet where it was shown there was this kind of now I lost that picture. I had it in my here. Here is I guess in many formula books written in English it is written like this. So here it is said that sinus A equals A divided by C, or opposite side divided by hypotenuse. So in this case we have this angle A or alpha here, so sinus A or alpha equals A divided by C. At opposite divided by hypotenuse. In Finnish, it is sini. In many Finnish words there are I. The last letter is I. Many international words, mostly which comes mostly from English or Latin language or Greek language, we get Finnish word by adding the I. For example, automate. In Finnish it is automaatti. And those examples are many. Actually, this sini, by the way, sininen equals blue. The color sininen in Finland. When we watch to the sky and it is very blue, we may say sini taivas. This is blue sky. Taivas is sky, or it means also heaven in religious mean. Sini is a shortened form of this sininen color word. Actually, this sinus, there is some kind of history there. I think you have heard that, but I before lessons today I was googling in the internet, and here was an old map from the places near to many of my students in online course and also in campus course are from the India or countries near India, Bangladesh and Pakistan and etc. And here's an old map of the it is Bengal Bay, I guess the name is nowadays. This part of, I think here it is more modern map, Bay of Bengal. And in this old map it is called Gangeticus sinus, or it might be written also in the opposite direction, sinus king, or sinus Gangeticus, I think in Latin they called that. And this sinus word is actually, it means bay or gulf, how do you say it in English? GULF. And there is some kind of historical mistranslation which caused that this word was actually taken in geometry or trigonometry in the place of this function which we nowadays call sinus. I guess the word came in originally. I think the original word came from or got its origin from somewhere in nowadays India, and that came to Arabic world, and in Arabic they didn't use vowel signs in their written language, and I guess some European Latin speaking mathematicians translated some words wrongly, and that they got some kind of idea that in this old maybe it was word of Sanskrit or Hindi language. I'm not sure. I'm not sure about, or I don't. I really know almost anything of history of India, but probably in in this Europe the mathematicians thought that in India they used the word for bay or gulf in the place of this mathematical function, and they took the same word in Latin language, and it was sinus, and that is the historical reason why it is used in mathematics nowadays. In Finnish, this sini actually it is the same as the blue color, but it is just a coincidence. It has nothing to do with the sinus actually. And then we have cosine. It was said that it is in this table or this formula here, which I robbed from the internet. There it is said that cosinus A equals B divided by C, or adjacent side divided by hypotenuse. It is easy for me to remember in Finnish language when we say koskettaa. We have this memory rule in Finnish mathematics, kosini koskettaa. This is like cosinus touches, and here kosini koskettaa, cosinus touches. So that means that if we have angle A here, or alpha, so we have to use in cosinus these sides which touches the angle or are near this angle. They are neighbors for this angle. They are B and C, so we get this B divided by C here. So actually in this cosinus we or every time we have all three letters A, B, C there, and one of these are either the large letter or capital letter, or then a Greek letter alpha. Cosinus alpha equals B divided by C. That is the way which that is a method how I firstly, when I was studying first time these trigonometric functions, I learned this memory rule in Finnish, kosini koskettaa, cosinus touches. And then we have this last, or not last, but if we take only these most popular trigonometric functions, then we have this last one is tangent, and it is division between these these cathets or these legs or the rectangular sides of this triangle, A divided by B. One memory rule also here is that in sinus and tangent we have the same letters here. So we have A here. If we have A here, then we have to start with A here in the right hand side. And same holds in tangent. If we have A letter here, we have to start with A letter here. If we change the angle, so we get B here. This angle B, which is the same as beta. If we have B here, so we must start with B here. And here, if you have here B, here must also be B. So it is easy to change the sinus A to sinus B, just changing the letters A to B. And in tangent, we have to remember that if we change this letter to B, so here must these be changes places. So there is B and here is A. Tangent B equals B divided by A. Okay, so if we take the next problem from that test, it was 23. This is in Finnish 23. Kaksi means 2, 10 means 10, and 3 means 3. So 2 tens and 3. 2 tens and 3. And what was it said here? By the way, in this test, I have to tell one thing. In this test, I used very accurate triangle value. Angle values there. For example, in this number 23, there was 4 decimals accuracy there, and also same as here. And again, in this last one, it was asked the answer should be rounded to 4 decimal places. That comes from my history teaching for civil engineering, because when civil engineer students are doing some kind of geometric measurements in the outside, they use theodolites and document. I don't know that kind of how do you say? Well, simply they have to use very accurate angles, so to get the lengths of buildings or building sites correct to 1 millimeter accuracy. So example here in this A length of side A, there was 3 decimal places, so this means 1 millimeter accuracy, and it demands that these angles must be in that accuracy. So we have now A equals 256.392 meters, and then we have the angle B beta 33.37 degrees. Degree is the same as aste in Finnish. Now we should calculate B. We wrote those formulas for angle A or alpha, but in this problem we have beta, so we have to change those formulas with the form that uses beta or B angle. Which trigonometric function should we use? If we know the length of A and the measure of angle beta or B, is it sinus or cosinus or tangent? I will write those functions here again with the B, angle B. Sinus B equals, as I said, if I have sinus here and B is the angle, we have to have B in the beginning in the right hand side divided by C. If we have cosinus and B and we have used the letter B here, so it leaves us only A and C, so here must be A and C. And then we have tangent B, and here again, if we start here with B, so here we must also start with B. So here is B divided by A. Remember that in tangent we always have these A and B letters. And in sinus and cosinus we have A and C or B and C. So which is the correct function to use in this problem? Cosine. If you use cosine, you now know A and you know B, and you could solve C from that. But we needed to solve B. Next quest or next knowing is tangent, and I think that may be correct one because we know A and B, so we know A and the angle B or beta, so we know this and we know this, and we have to calculate this. So this is the one we get from we get the answer of the question. Well, of course, this is only a test question. Many times when we have some kind of triangle problems, the most common situation is that we need to calculate everything. We have to know all angles and all sides, all lengths of sides. So actually this answer cosinus is not a wrong one, because with the help of cosinus we would get the length of C, and it is okay also, but in this problem we were asked to solve only this b. I'm hearing there some kind of small child speaking there. Thank you. Or maybe she or he was asking something about my problem there. Okay. Well, we got this tangent b. So now we knew this beta here. I will use that beta now. So now tangent beta equals b divided by c, or I don't write the numbers yet there, but let's see. We now know beta and we know a. We have to calculate b. How do we get b from these two? Do we divide or do we multiply? Multiply, yeah. So we here get b equals a multiplied with tangent b. If you are not sure, compare with easy numbers. For example, 2 equals 10 divided by 5. And now we have to find out what is the value of b. So in this equation we have to know what is the value of 10, or how do we get this number 10 with numbers 2 and 5. So we see that we have to multiply these. So in this equation the same holds. To get this b, we have to multiply a and tangent b. So now we put these numbers in that equation. I don't have enough place, so I will write again here. A was 256.392 meters times tangent like that. One thing when using the calculator is to be sure that you are having correct units in it. For example, this calculator is quite good calculator, and there in Finnish it is in Finnish language, but here you can see aste word. As I told, it is degree. So this is in correct units. But there could be written also some other unit, for example, radians or gradients with a G letter in front of the word, in the beginning of the word. But for example, this calculator, you can see DEC text, DEC there in the screen. So this is also in correct unit. Then I have one calculator which is almost similar as this red one here. This black one is older one, and it is there are some differences between these calculators, but almost the same. But the one difference is that in my this old black calculator, you can't see the unit there. It is quite stupid, because in this calculator you can't see what is the unit of angle. So always, if you have such kind of calculator, one good way to check the correct unit is calculating what becomes if you calculate with the this calculator sinus 30 degrees. For example, if I do it with this calculator, I take this trick button here, and there is first this sinus. I don't know why does it so. Probably now it is seen better. If I write sinus there and push enter button, it becomes half. Or if I take it with decimal format, it is half. So I know that this calculator is in the mode where the angle unit is degree. Of course, I could see it also here. But for example, in this calculator, because I can't see the correct unit, I have to check it. So I do the same, sinus 30. And this also gives half. But for example, if you have this kind of situation, I will show with this calculator again. As you see, I changed the unit. There is rad there in the. There you probably can see the word. Now if I take 30 degrees, so there is sinus, I will put, so it will give something like that. So this tells that you have not correct unit. And of course, in this calculator, you could see that the unit is radian. And here is the way to change the unit. There are different ways there is almost the same word, G-rad, gradians or goons, and now it is degree. And now if I take it again, 30 degrees, sinus is half, 1/2. Using mobile phone calculators, it is, I'm not so pleased with these calculators, but I know that many students use this. I will try to show. This is the simple calculator, but if I change the like this, this is somehow stupid, at least this application, because there it is said that it is rad. I may push that. Now it's dig, and for me, if I can't see any units there, I would think that now it is in radians. But when I calculate sinus 30, it will give 1/2. This is, in my opinion, very stupid. Now if I push this radian button here, now it tells me that the unit is radian. And as you see, now it calculated it in radian units. But somehow in this, when you have the calculation in unit degree, I don't understand why don't it show the unit right now. So I would suggest that if you use your phone calculator or calculator in your mobile phone, check this sinus 30. It should be 1/2 if you want to calculate in degrees as you mostly want. Or it depends on case. In some physics applications, there you have to use radians. And if you are making some surveying, land measuring calculations, then mostly you use this. I had this calculator here. This is radians and this is gradians or cone units. But this is mostly used only in some kind of land measuring problems. But at this point we usually use this degree. I also have this kind of calculator here. I will check how does this work. Yes, it is shown the unit there in the top part of the screen. Sorry, I can't show it very clearly with my camera, but there it shows degree. So now finally I calculate what does this length of B become. Oh, it is correct. As you saw in a habit, I wrote that comma here again. Again, I will put some extra decimals there before I am rounding. This is a good way to do, or good habit. I would suggest you to do same. Not round immediately, but first the more accurate number, but after that the rounding. And here it was said that the answer should be in meters, so we are getting it in meters and round it to 3 decimal places. So when we have length of meter in meters, so this 3 decimal places means accuracy of 1 millimeter. And here again, here are 3 first decimals, and the next number or figure there is 5, and this 5 rounds this up, so it will become 891. 168.891 meters. That was the 23. 24. What is the length of A if B is, we know B and beta. Problem 24. We know B equals 242.204 meters, and beta equals, actually this was quite boring example or boring exercise because it is so near of that 23. I have a Excel sheet which gives me random examples concerning, for example, rectangular triangle problems, and now it has happened that this problem 24 and 23 were almost exactly same. There are the same letters in the problem, so it is much more easier than if you could solve the 23, probably you could solve the 24 also. Now we again have angle beta or angle B. Yes, there was a question. Good calculator for our course, please. Um, well, what is the good calculator? It depends on how much you want to invest. Actually, I know the price is only in Finland, but for example, this kind of calculator in Finland, it goes almost 200 euros. I guess 150 euros to 200 euros in that between that area. This is very good calculator, but I'm not sure if it is wise to invest so much to calculator. I've got this from my employer, so uh, sorry, what is the employee? The school in which I am working, it gave me this calculator, so I didn't have to pay it myself. But then there are good calculators. For example, this calculator is well enough. It is okay, and in this calculator also have possibilities to solving equations and solving systems of equations, and there are also uh, matrix calculations there. So there are enough for what you need, and the price of this calculator is about maybe 30 or 40 euros, so it is much cheaper. And I always say that the 200 euros for a calculator is not good price. And of course you handle with these simple function calculators still. These old are very good calculators, but of course there is the restriction that there are no any solving possibilities. You have no possibilities to solve any equations with this calculator. But still, I am quite not sure what is the need for calculators in your future studies. I think it is good when you have some teachers who teach you in your how do you say, in your professional uh, subjects. Uh, uh, Maybe it would be good to ask if they need any calculators, or do they only use some kind of a computer programs. For example, in this course we will start using a simple computer program which gives a possibility um, to calculate some simple problems without any need to calculator. So uh, I'm not sure. It depends on you. If you have lots of money, you are swimming in gold. So then you may buy a expensive calculator, but at this point I don't think it is so necessary. It is possible to use uh, your mobile phone calculator, or then sometimes you may use some computer program or application from internet to solve those problems you need. But I will come back later to this discussion when it is actually the time to it. Well, as I said, this this problem here is almost similar as the 23. We have the same letters here. Here we have A, B, beta, and here we have A, B, beta, but the unknown is the different one. But still it means that we again use this same function tangent. We have tangent beta equals B divided by A. If we have A and B in problem, so it will always will be tangent the function, because in sinus and cosinus there always is C, and if we don't have C in this problem, either we don't see, no C, or either or we don't and C is not unknown, so in this problem we don't need sinus or cosinus. It only possibility is to use the tangent. But the difference is that earlier in this problem we had the unknown in the top part of the right hand side, and we solved this by multiplying these two here. Comparing was this problem, and now if I will write the comparing here again. If you compare 2 equals 10 divided by 5, and now we have to find out what is the A, the value of A, and it is in the same place as this 5 in this easy equation. So now we think in our mind or in our heads that what will we do with 10 and 2 to get 5. We are not multiplying them. We are not multiplying 2 times 10, but we are dividing, yes. And the dividing should be so that 10 is divided by 2, not in the opposite direction, not 2 divided by 10, but 10 divided by 2. And here it means that we get this A by dividing B with tangent beta. So this means that now we get this A by dividing B with tangent beta. Of course, you may solve these kind of problems also with this very easy way. I will take that first for this number 23. We wanted to get no, I won't take that because it doesn't hold in that problem. But in this problem, we have the unknown here in the bottom part. So if we watch this solution here, what has happened? So we have only changed the places of A and tangent B. So if we have this kind of equation and unknown is in the bottom part of the fraction here in the right hand side, so we only have to change the places of these two. A goes to the left hand side and tangent B goes to the right hand side. So it is easier to solve those kind of problems. And now we will put the values there, so there will be B divided by tangent B beta. So it will be like this. I will show with the cheaper calculator that this is okay also. Not necessary if you want to buy a calculator in which there are solving possibilities. You many times see the word solve there, or here you see num solve polysolve, syssolve, numerical solving, polynomial solving, and system of equation solving. And this calculator, there are many calculators which are almost the same calculators, but not necessarily Texas Instruments calculators. For example, Casio has good, and many other uh, brands also. And this also gives me possibility to use this kind of letter here. You may put this line there between top and bottom parts of division. So I may write this exactly as in the paper. 204 divided by tangent and angle. So this is, I like this calculator. It is good calculator, and here you get the answer. $394.70887, etc. meters. And again, the rounding should be to 3 decimal places. It was said here, 3 decimal places. So here is the third decimal. It is 8, and after that, next figure is 8. So this will be rounded up. 709. Okay, I think this is enough for today, because we didn't have any break, and so the lesson should, with the break, it should have ended in 9:45. So I think it's time to end today. During a weekend, I probably, or at least I try to put some exercises concerning this right angle triangle to the Moodle. Right now I have not, I have something, but I'm not, they are not translated to English, so it takes time to take that translations. Next week I will go through these last two exercises there in the test, and then we probably will practice these geometry problems sometime, and then we will go further in algebra and also in geometry. But now I thank you for this week, and have a nice day and a nice weekend, and we will meet again. I guess it was Monday, and Monday I will again be at my home office. So I think I have to say that I have better document camera at my home office, and I like to be there more than in this small studio where I am sitting right now. But thank you for for today and for week, and let's see next week. Bye bye. Hei hei. Hyvää viikonloppua. Have a nice weekend. Yeah, thank you.